Welcome, and we're just going to revisit those examples that we just went through in a slightly different way. Now, this one, and if you read the instructions carefully here, it doesn't say that you have to use transformations, and so we're going to not use transformations. Okay, so just make sure to read the instructions as always and adhere to them whenever possible. But if there's no method specified, you can feel free to take whatever liberty you want. Okay, so the way I'm going to approach this is still by, I have to identify the amplitude. Okay, so this stuff hasn't changed. So I know that the amplitude here is 3. The period is going to be 2 pi divided by b, which is 5. And then the phase shift is just going to be my horizontal shift. So this one, it's going to be c pi over 2, because remember it's b minus c, c over b, 5, and so this ends up being pi over 10, okay? And then you can also talk about your vertical shift here too, and that's still 0. So nothing has changed from that regard. What is going to change is how I use those increments that we were computing, right? We computed the increments, and we said, well, I know that the angle for one full cycle of cosine is between 0 and 2 pi because that's the period of cosine. And right now we're treating this as the angle for cosine. So for us, one full cycle should be between 0 and 2 pi, and that should be represented as 5x minus pi over 2 and less than or equal to 2 pi, okay? And now I can just use algebra to simplify this compound inequality. So add pi over 2 to all components. And here I get 5 halves pi, or 5 pi over 2, okay? Divide by 5, okay, I need to come up here. And I get pi over 10, my phase shift, less than or equal to x, less than or equal to pi over 2. Okay, so now I have this cycle, or I have kind of one period of this, and in this period, cosine is still going to follow that same general pattern if I know where those key points are. Okay, the key points are going to occur according to the increments. So I take the period, so the increments, 2 pi over 5, and I divide it into 4 pieces, and after I simplify, I get pi over 10. Okay, so what that means for me is I can take my graph and start counting by pi over 10s, right? And that happens to line up with our phase shift. So let's call this first one pi over 10. This next one would be 2 pi over 10 or pi over 5. And then 3 pi over 10 and 4 pi over 10, which is the same as 2 pi over 5. And then the last one would be right here at 5 pi over 10 or pi over 2. Okay, and then what I know is that in this range of horizontal values, if I think about my normal cosine graph, let's call this 1 and this -1, that cosine should follow that maximum 0, minimum, oops, missed one, minimum, 0, maximum pattern with its key points. Okay, you can confirm this. Okay, so you would have these general points. Now the only thing that I haven't taken into account is the amplitude. So all I have to do is make sure to stretch this vertically by 3 units, 2 and 3, and similarly here 2 and 3. And so my final graph should be just 3, or 3, 0, minus 3, 0, 3. Okay, and so here I was able to construct the graph. I didn't have to use transformations. All I did was I used the interval for one period. So I knew that the period for one cycle of the graph would be between pi over 10 and pi over 2. Okay, and then I used the increments and said, okay, with those increments, those are going to be the places where cosine is either maximum, a minimum, or 0, based on the pattern of points. And I know cosine is generally maximum, 0, minimum, 0, maximum pattern. Okay, so that's one example. Okay, now I'm going to try the same thing with this example here. Okay, but before I do it, I want you to pause the video and try it out for yourself. And when you think you have the solution, resume the video. All right, so I paused the video and did some work, and so you can see amplitude, period, phase shift, vertical shift, that's all the same for this example from the last video. What we have to use now is that period, the period approach and the increments. So the periods, or the one period of this function is going to occur between -1/6 and 5/6. Okay, so fractions, it's okay. Better than working with non-terminating decimals. So there we go. But you can see the work that I did here. And then the increments, remember this one is the period, and then I just divide that into 4 to find where we have the maxima, the minima, and the zeros. Okay, so now the tricky part. We got to graph this thing, right? And so you can see I have the graph kind of set up. I incremented according to what I calculated, 1/4. And so you can see the horizontal axis, I have that enumerated. Okay, the vertical axis, I have that just counting by ones because my amplitude is pi. It's not going to be the prettiest thing to graph, but we'll make do. Okay, and the vertical shift, pi over 4, that's approximately 3/4. Okay, pi is about 3.1, round down, tomato, tomato. Okay, so again, this is just a sketch. Okay, if you wanted to do this precisely, you do it in decimals. Now, to graph this thing. Okay, so what I know is that sine, when I think about the sine curve, right, it starts with 0, maximum, 0, min, 0 to those critical values, right? So I'm going to follow that same pattern. I'm just going to place the 0, the beginning 0, at wherever I had my phase shift, so -1/6. Okay, so 1/4 is, 0.25, 1/6 is about 0.16, so it's here-ish, okay? And then from there, I would add 1/4, okay, which would put me right about here, and then I'd be up at the maximum, okay? And then I'd be down at the minimum, or at the next 0, which would be right, oops, actually, I'm sorry, I have that incorrectly placed. It should be right about there. Oops. Right about there. Okay? 0 maximum, 0 minimum, and then 0. Okay? That's the general idea. Okay? So I'm following that that sine curve here just by adding, if I started -1/6 and then I add that, and 5/6, I should end about 5/6, which is about 0.875. So I might have to adjust the points a little bit, but we have the idea. Okay, so now I have it kind of taken care of horizontally, right? I'm between this for the period, and I've incorporated that phase shift in there. So now all I have to do is stretch it vertically. And so I know I have to stretch it by pi and then shift it up 3/4. So you can kind of do that in the appropriate stages. So you'd stretch first. So stretch by pi vertically. So you'd be at these red points now and down here-ish and there. Okay, and then lastly, I need to shift it up by this 3/4. Okay, so I'd shift it up here. Oh, say about here, there, up there, and up here. Okay, and so this purple graph is going to represent the final graph. Here I kind of made use of the transformation idea, but I didn't do it step by step. Okay, so know that you don't need to follow the method of transformations if the instructions don't say so.